So the next topic that we are going to talk about is overall heat transfer coefficient. So we briefly talk about this in chapter 3 when we introduce the concept of resistance. So when you are dealing with heat exchangers, we will be always using this concept. So we will be always replacing H with U. Because, so we need to think about conduction in combination, conduction in combination with convection, and convection could be from cold side and hot side. So when you are thinking about overall heat transfer coefficient, so we have to consider all of these effects together. So for instance, if you focus on this, the wall between the hot and cold fluid here, so we have a wall, we have convection from inner side, convection inside, and convection from the outside. Okay, so we have two convection terms and one conduction term. So if you want to write down overall heat transfer coefficient, so we want to be careful. So you can be defining overall heat transfer coefficient with respect to inner or outer wall. Okay, inner wall, outer wall. So if you are defining it with respect to inner wall, so you are getting the overall heat transfer coefficient with respect to inner wall. So this is also equal to overall heat transfer coefficient with respect to outer wall times outer surface area. So this is the total resistance, or R total. Okay, 1 over HI AI, 1 over HO AO, and R resistance of wall. So if the wall is thin, so that means you can neglect the wall resistance. That means AI is almost equal to A out. So the overall heat transfer coefficient is simply 1 over HI plus 1 over HO. Okay, so that is basically the main observation here. So however, so you must realize this is very idealized situation. In reality, in industrial practice, you always have fouling. So you may have antimicrobial, so you may have microbial agents that are gradually building up some slime. You may have some corrosion. You may have some deposition of impurities. So you'll always have fouling. So there's always fouling. So sometimes fouling can be so severe that you may be almost losing half of the flow. So it is actually, you need to gradually clean this. So you can imagine this is a big problem in industrial practice. So that means when you are dealing with this analysis, heat exchanger analysis, you cannot just neglect the fouling. So you need to consider the effect of fouling. So for instance, if you may have fouling inside, you may have fouling outside. So you may have two foulings. Let's say if you are focusing on this wall. So we have convection inside, convection outside, fouling inside, fouling resistance inside, fouling resistance outside, and then the wall resistance. Okay, so most of the typical representative fouling factors are tabulated in this table. So depending on what kind of fluid you use, so you may get a different kind of fouling resistance, and these are tabulated. These are per unit area. Okay.